Question number 2 on the Exploration 3-2b asks you to write a particular equation, specifically a cosine equation, for a sinusoid curve that they give you. So the first thing you're going to want to do is figure out what the measurements of this are. If you check to see where the top and the bottom of the curve are, the maximum and the minimum, run a line straight across. You can see that the minimum there is 10, the maximum is 100. That means that the difference there, the distance from one to the other, is 90. And if you cut that in half and draw a line at the midpoint there, that's called the midline. Sometimes it's called the sinusoidal axis, a fancier word for midline. The next thing you're going to want to do is check to see what the period is. The period is the distance from one point in a cycle to the same point in the next cycle. In this particular case, we're measuring from the top of the curve to the next top of the curve. You could do it from bottom to bottom. When you do, it'll still be 30 degrees across from place to place because that's how long the cycle is. The next thing you want to measure is the height from the midline. How far up and how far down does it go? Obviously, those two numbers should be the same because it's the midline. So if it's not the same, something was wrong when you drew your midline. Also, it should be half of the distance between the two maximum and minimum lines. So in this case, it's 45. The next thing you want to measure after that is how far to the left or the right is what would normally be the part of the graph that's at 0 on the x-axis. The cosine curve would start at the maximum on the y-axis and go from there. A sine curve would start at the midline and go up from there. In this particular case, since we're doing cosine, you're looking at a shift to the left for the maximum of 3 degrees. Now what we're going to do is give names to those measurements. The midline, I've already mentioned, it's the sinusoidal axis or the midline. The period is the distance from one point on the curve to the same point in the next cycle on the curve. That's called the period. The amplitude is called the distance from the midline to the maximum or to the minimum. And the phase shift is actually the horizontal translation, in this case, to the left 3 spaces. Now, those are the numbers that go into the equation. The form of the equation is y is equal to c plus a cosine of b times the quantity theta minus d. Different books use different letters, but the form is always the same. The only one here that's tricky at all has to do with the period. The period, which is what we measured, is equal to 360 degrees divided by the absolute value of that number b in the equation. What you get is that the absolute value of b is equal to 360 degrees divided by the period. In this case, we have 360 degrees divided by 30, and that gives you 12. And that's what goes in where b was in the equation. And if you'll notice, we've put that in green, where the b was. The next thing you want to look at is the amplitude. If you look where the yellow is, you'll see I've put an a there. The a in the equation is where the number for the amplitude goes. So we put 45 in for a in the equation. The next thing we look at is the midline. If you look on the left where the 55 degrees is, you'll see C. That's the number for the midline. And that goes where the C is in the equation because that represents the vertical translation, the shift. In this case, it's 55 spaces up. D is the phase shift, which is also the horizontal translation. And you'll notice in this case, it's negative 3 degrees. It is the number D. If you put it in for D, you'll notice that it's theta minus D. So in this case, what you have to do is put the negative 3 in for D, so you now have theta minus negative 3. When you write it out, it's going to turn out to be positive. So that is the equation. And what I've done is put that into Desmos. I wanted to check to make sure that I had the right equation. And sure enough, it looks like I do. If you look at the very top on the left, you see that there's a maximum point at negative 3. if you follow across, you'll see that the next maximum is at 27. So that is 30 spaces from place to place. You'll see that the midline is at 55. All of that worked out. This is the graph that we were trying to find in the equation of. Then the next part of the problem, or the next problem, says rewrite it as a sine equation. So the first thing you need to recognize is that when you turn it into a sine equation, there's not a whole lot that's going to change. If you keep the 55, you're maintaining the midline. If you keep the 45, you're maintaining the amplitude. The 12 represents the distance from the top of one curve to the top of the next. And you wind up with this curve. The question is, how are you going to get it to look like the other? One thing that's important to notice is that on the new sine curve, the maximum happens at 7.5. And what you want to do is shift this red curve so that it matches with the green one, because that's the equation you're trying to duplicate here. So if we recognize that the maximum point occurs at x is equal to 7.5, we can look to say, oh, okay, then I need to move this whole curve to the left by 10.5. If we move everything 10.5 spaces to the left, we will have the curve that we're looking for. And we do.